Conveyor me and you.
Yeah, hello friends. So today we are going to see a sorting system, sorting materials by color. As you can see here, when I have my start button, that is what happens. So we are going to see ladder logic programming step by step. We are going to see factory IO setup step by step. We are going to see MX configurator step by step. And we are also this time going to include the counters. We are going to include some alarming mechanism just for the sake of learning. Are we there? Yeah, just for the sake of learning. As you can see, we are separating 3 different colors. We separate blue, green, and then gray. So we have to separate all those ones. Each one will go in its respective place. What we have very many components, as I'm going to explain when we start up the tutorial. Here I'm just letting you see what is happening. So I think we can go and see what happens. There we go. So what we are going to do, I'm going to start by setting up the components, and that is the factory IO software we are going to open. Please don't forget all the links to these softwares are in the description. So there we go. Yeah, so now we are just going to use some inbuilt scene here. Going to come to scenes, just scroll down. We are going to come to sorting station, separate green and blue items using a vision sensor. That's the main thing. We are going to use a vision sensor or a color sensor. Yeah, so there we go. Remember I told you we are going to add some alarm and some warning lights. So we are going to come to pellets here and scroll down. Then I'm going to drag and drop this alarm. Hold Z to move it up. Then you release. I'm going to move it to this box just on top. Then hold Z to bring it down. Right there. I'm also going to have some warning lights. Drag and drop. I'm also going to place it just here on the top of this box. So we have this one is the warning light 0, you can see here, and this is alarm siren 0. Those are some of the output devices we are going to use. So another output device, we have this conveyor here is called entry conveyor. When I put play here, when I say play, you see that is entry conveyor. You can release it here, don't leave it first. Then we have other output devices this way. Now we have here the sorter belt, then we have sorter turn. So this one I'm going to call, this one is, let me rename it, I'm going to call it blue belt. Blue belt. Then this one I'm going to call it blue turn. Blue turn. You have renamed them. When I power it, you see how it does. Then the belt, it allows the item to rotate over it. You see the way it moves. You switch off. Don't leave them first, you release. If you leave them first, they will not be able to be controlled by the PLC. We have here sorter turn 2, then sorter belt 2. This one I'm going to call it green belt, and this one I'm going to call it green turn. Green turn. Oh, it's not renamed. Green turn. So here we are just trying to go through how to set up our factory IO. Then I will do away with them. They are already named. Then I have another one here, the third one. I have here exit conveyor. I'm going to leave it as exit conveyor. Then I have sorter 3 belt, sorter 3 turn. This one I'm going to call it gray belt. And delete this one, call this one gray belt. Then I'll call this one gray turn. This is gray turn. So there we go. That is, I think, the customization I wanted. So those are the output devices. Those are the only output devices that we have. So now the input devices, we have this one is our vision sensor here. I'm going to leave it the name vision sensor. So first of all, how does the sensor work? When I switch on this entry conveyor, we are going to set our emitter. This one is emitter. Click on it. Firstly, stop the simulation. I can remove these palettes. View palette, remove. Then come click this, then right click. Then you are going to choose parts to emit. We are going to uncheck this, uncheck this, uncheck this one, uncheck this one. Leave only blue raw material, green raw material, and metal raw material. Metal raw material is going to provide us a gray color. So from there, then you have simulation. Then let me first do a manual way. We see. So I'm going to put on entry conveyor. When I start entry conveyor, I just want you to see how the vision sensor varies the colors. So you see here it is 4 green. The vision sensor gives us a value of 4. Let me refresh here so that I can get a difference. So here I have a blue. Let's see the figure the vision sensor is going to give us for the blue color. Yeah, the good thing, they are coming, 2 of them. So the blue color is giving us 1, figure 1. So when I remove this one and I allow the gray to come, we see gray. So gray has given us 7. So that is how we are going to, don't leave this one first. That is how we are going to differentiate those colors. Our vision sensor gives us a value 1 for blue, value 4 for green, then a value 7 for gray. So that's what we are going to use in our ladder logic programming. Also, other input devices, other outputs. This time also we are going to use counters to count how many blue, how many green, and how many grays. We have the start, stop, emergency, and the reset button that we are going to use. Then we have also, apart from the vision sensor, we have another sensor here, this one around here. Click stop to click it properly. This sensor around here, it is called at exit. This one I'm going to rename it and say exit sensor. It is called exit because it senses when the object is already leaving the sorting conveyor. So I'm going to call it exit sensor. What? So those are the only input devices that we have. The input devices, we have the vision sensor, we have the exit sensor, we have start, stop, reset, the emergency. I think they are those ones. Then the output devices, you have entry conveyor, exit conveyor. Then you have these turn sorters, the 3 of them, a sorter plus it is belt, a sorter plus it is belt. So that's how we are going to deal with our factory IO, and it is all done. So what I'm going to do next, we are going now to register variables in our MX configurator. Let's go. I'm going to first minimize this one. Don't close it, just minimize. All you can do is maybe you can save your project. Then now we are going to come here to our MX OPC configurator and we start the software. So here I'm going to come here, file, new. I get a new project. I'm going to call it sorter. Just going to call it something sorter here, and say save. So now This one I'm going to right click and get new MX device, and we are going to come here to configuration. Then I'm going to use GX simulator 2, and I'm going to use the CPU mode FX CPU. Then I'm going to say next. You can emit that one. So this is GX simulator 2 FX CPU. Then I say okay, then I say yes. Then again I'm going to right click to start new data tag. So now here I'm going to start with the vision sensor. Since it is just going to fetch data, it's going to be inputting data in the CPU. Here we are going to use a register called D0. Then I'm going to say save new. Now I'm going to have a blue counter. It's going to fetch data from the register D1, which is already there. Save new. I'm going to have a green counter, which is going to fetch data from register D2. I'm going to have save new. Then I'm going to have a gray counter. It's also going to fetch data from the register D3. I'm going to say save new. So those are the data registers we are going to use. Now let us register the input devices. I'm going to have X0, I mean emergency, which is going, now it is not data registers, this is input devices, and it's going to be X0. Save new. I'm going to have stop, it is at X1. Save new. I'm going to have start, which is already at X2. Yeah, save new. I'm going to have the sensor exit sensor, which is already at X3. Save new. And also those are the input devices that we are going to use. They are done. That means next is inputting the output devices, which is Y. We start with Y0. So the first output device I think we are going to use, let me see. Okay, the first output devices, let it be entry conveyor, that is Y0. Save new. The next one is going to be exit conveyor, which is going to be at output Y1. Save new. The next one is now going to be the turners, the sorters. So I'm going to have here a blue turn. Don't space. If you space, is going to refuse. And I say save new. Then after a blue turn is going to be together with a blue belt. The way we were renaming in the factory IO. Then here I'm going to have green turn output. Save new. Then I'm going to have a green belt. Green belt output. Save new. Then I'm going to have a gray turn. Save new. Then I'm going to have a gray belt. It is not a gray belt, it means the gray turn means that sorter that's going to be turning the gray materials. Yeah, it is going to be at Y7. Save new. You see from Y7 it jumps to Y10. That means the CPU series has no output Y8, Y9. So it's going to go to Y10. So this one we are going to give it alarm and save new. That's Y11. We are going to give it warning light. Warning light. Thanks for being so patient. Please watch the video up to the end and you'll enjoy. So this is done registering our inputs and outputs. Then just say yes. That means we have only here 4 inputs and we have 7, 8, 9. We have 9 outputs. So that one is done. When you come to, you can put it in monitor mode. You say yes, setting it as the current database. Then come double click here to view them. Yeah, right now, yeah, quality now all good, all good, all good. So we are going to minimize this one. Also, we have already registered our inputs and outputs. Now where we are going is to GXWorks 2 and open, and we start up our ladder programming there. So we are going to minimize this one. Don't close, just minimize. All we can do is save your project. Yeah, we are going to open our GXWorks 2 software. Tewe pima nange never compare me and you. Tewe pima nange never compare me and you. Wepime nabo nabo wepime nabo. Yeah, that was a bidder. So now here we are going to come project new. Here make sure that you use FX CPU, because remember in our MX configurator we used FX series. So just you can leave FX3U stroke FX3UC, ladder logic, everything leave the way it is, just say okay, then to create our project. Yeah, it's going to give us, that is our first rank. Now here, just be keen, I might be a bit slower, so just because I want everybody to be at the same pace. Okay, now we are going to have, remember I'm going to use here a normally open as my emergency X0 input, because my emergency switch, the real one in the factory IO, is a normally closed one. Also I'm going to use normally open for a stop, that is X1, and I'm going to use a normally open for a start, that is X2, and I'm going to have my memory here, that's M0, and I'm going to do some latching here, that is self-holding of memory M0. So X0, X1, X2, you all know what it is. We were registering them in MX configurator. You can take back the video and review. So that is it. Now I'm going to start the system with this normally open of M0. After that, I'm going now to use instructions. I'm going to use here a compare instruction. Come here to F8, that is instructions. You click. So I'm going to use a comparison and operator equals. So I'm going to say equals K1. Remember, in our sensors we have three figures. We have 1, we have 4, 1 for blue, 4 for green, then 7 for gray. So now here I'm going to say if K1 equals D0. D0 is the data we are getting from the vision sensor. Remember, we registered D0 as the vision sensor. So K is just a constant. So if K1 equals D0, that means if D0 equals 1, this instruction is going to complete the circuit, and it is going to be broken. That circuit is going to be broken by an exit sensor, which is X3. So it's going to power memory M1. So this one means this instruction is going to help us deal with the blue, to recognize the blue material. So I'm going to put some branch here, and I'm going to put counter, just the coil, and say I'm going to call it C1, counter 1, and I'm going just to give it a maximum value 99. That is C1 K9999. So this switching mechanism here, this switching instruction, I'm going to latch it to self-hold it. So I'm going to self-hold it with the M1, and I'm going to come here to put line F10. Just going to draw a line here. I draw a line here, and we also draw here, and also draw there like that. So that one is the first one, which is going to help us detect the blue object. Then let's have the second one to detect the green object, that is M0. We are also going to have an equal instruction, which is F6, F8 here. Instructions say equal, Okay, 4, that is now 4 is the value for green color, D0. So D0, if the value coming in the sensor, if it is equals to 4, that instruction is going to complete, is going to be broken by X3, then it's going to power memory 2, and also we are going to select hold here by memory 2 contact. I'm going to come to F10, it is still there. I draw here this line like this, I draw here this line like this. So that one, also this one, I'm going also to put some branch here and put counter 2. I'm going to call it C2. I'm just also going to give it a maximum value of 9999. You say okay. That is how you are going to be detecting blue. Now I mean green. So how do we detect gray? I'm also going to have this open contact. I'm going to have instruction equals K7 D0. So if the sensor value D0 is equals to 7, this one is going to complete also, and it is also going to be broken by the very X3. X3 is the exit sensor. Then I'm going to have this coil M3. I'm also going to create certain branch here and put counter, that is T3, also going to give it just a maximum value like that. So that's how there is self launching here of M3. I'm going to put this line. To draw these lines the way I'm drawing them like this, you have to have here F10 active. If it is not active, they are not going to draw it. That means you have to use this F9 and SF9, that is shift F9. So that is how, and come here, compile build for a better view. That's how we are going to be detecting those colors. Now we have to send these counter values to our counters in factory IO. I'm going to have this one normally open of M0. So we are going to have another command here, a move command. We are going to say move. We are going to move the value of C1, that is the counter 1, to D1. Remember, in our FX D1 we gave it counter for blue. So D1 is the figure that is going to display on a blue counter. We say okay. We are going to have a branch here, and we are going to have again a command move D2, I mean C2, that is counter 2 to D2 value. We say okay. We are going to have another branch and still instruction say move counter 3 value to D3, register D3 value. So that is how the counter values are going to be going to our factory IO. For any inquiry, please, where you're not getting, feel free to post in the comment section. I'll handle you, and I will handle your issue, only to those who are serious. So that is how we are going to move those values to counters. Now let's start the logic. As soon as we start, we put the start button. We are going to have M0. We are going to start. The exit conveyor is going to be on. Exit conveyor, that's my design, is going to be on as long as overwrite or it's just going to remain on. So that is an output of Y, and the exit conveyor, remember, it's Y2, is going to be on. Then the M0 is also going to start the entry conveyor, which is Y, which is Y0. This one is not Y2, this one is Y1. Let's say Y1. Okay. This entry conveyor of mine is going also to be started. It is going to be started by sensor X3, that is the exit sensor. That means it's going to be stopped by, it is going to be stopped by M1. So when the object is sensed, the conveyor will first have to stop to prevent congestions. You're just going to see when it is simulating. So it's going to be stopped by M1, it is going to be stopped by M2. That means any color that is detected is going to stop the conveyor, and it is also going to be started by this one. Yeah, I think that is it. And for that case, I have here also it has to self-hold itself, and that is Y0. So that is the entry conveyor logic. You can compile this. Let me compile this for you for a better view. So now we are going to, turning is now easy. Once our system is on, that is M0, M1 is going to turn. That is M1 is going to power on the blue sorter, which is the coil here, and it is Y2. I'm going to have a branch here. It is going to turn on sorter turn, blue turn with the blue belt. Also for green turn, green belt. For gray turn and gray belt at the same time. So here, this one is Y3. And this one is going to self-hold. No need to self-hold. This one also, once the system is on, that is M0, M2 is going to start it, and it's going to start now the green, which is Y4, with its respective belt, which is Y5. Very good. Also this one, once the system is on, M0 is going to be started by M3, and is going to start the gray turn, that is Y6, with its respective belt, which is Y7. Compile, build. Hope we are moving systematically with our ladder programming. Don't think that this is the only way you can do it in your own way. What we are all after is the functionality. So I'm going to include the reset button. Oh, I did not include the input for reset. Okay, whatsoever. Let me ignore reset. Here we are just going. Now we are putting the logic for the timer. If the system will be on, then we have M1, that is the blue sorter. Then I'm going to put it in a parallel with the M2, that is the green sorter. Then M3, that is the gray sorter. It is this contact here, M3. Put it around here, then shift F5, then M3. That is okay. So that means either blue or green or gray, which is detected. Yeah, it is going to power on a timer. That is, I'm going to call it T0. I'm going to give it 15 minutes, and 15 minutes is 150. It is K150. That means 15 minutes. You say okay. What will happen when those 15 minutes elapse? When the 15 minutes elapse, it's going to power on Y. What was the next? Y10. That is alarm. At the same time, the warning light, which was Y11. Okay, this one is timer 0. Don't forget to name it. It is T0. So I'm going to compile this for a better view. I think we are done with the ladder logic. Let me first go through and see. Hope it is okay. Now this warning, the alarm logic I've put in is that when there are times a blue object can go away, then it is sorter fails to go back in the normal position. Like a blue can be sorted, the sorter turns but fails to go back. and yet the system has to start. That means the system is going to remain stopped. That means the alarm is going to be initiated. You are going to see how it's going to happen. So here I think the thing is okay. Come here to debug, start stop simulation. It says multiple projects cannot be simulated. Okay, I have already a project in simulation. Sorted. You come here to debug. It says start stop simulation. Now when it gives that warning that, first check this, when it gives that warning that multiple projects cannot be started simultaneously, what you do, you just go to our MX configurator, first click stop button. After clicking stop, come back to debug, then start stop simulation. It will be fine. Then after stopping simulation, you can come back to our MX configurator and click play again. So after clicking play, it has to give us here quality good. That means we are ready to go. So after simulating all, we minimize all this and we open our factory IO project. Now you are going to come, you can click here where there is none, or just easiest way, come here at file, select drivers, and here none, come and select OPC client DS/UA, then wait for it to search. Oh, it can say server not defined. It is okay. Now before we look for the servers, I think you can see the input devices we had vision sensor, we have stop and start, then we had at exit, that was the sensor at exit. Then the output, you have alarm siren, you have counter 1, counter 2, counter 3, that is blue counter, green counter, and let's first rename this counter. Let me go back and first zoom this control board here, then click on this word here, this one counter 3. I'm going to rename it gray, which is okay. As you rename, you will see here changing the name also. So I put here counter 3, you rename it gray, you say enter. Here it changes also to gray. Come and click here counter 2, rename it blue, I mean green, you say enter. Then counter 1 is going to be for blue, I think can name blue counter for easy understanding. Blue counter also here down, green counter also here down, name gray counter, enter. Now you can remove them, just remove. So now when we go back to files, drivers, you'll find we have here the outputs. We have blue counter is this way, green counter is this way, this is gray counter, and where is green counter? Don't have green counter. Let me go back and check. It didn't enter. It is green counter. Enter, remove. So when we go back to file, drivers, they are there. So now what we are going to do after that, just come here to configuration and browse servers. You give it time to search. After searching, they will be listed here in this OP server box. Select Mitsubishi. After that, browse nodes, then go back. don't forget to browse nodes. It will bring all the way we're registering in our MX configurator. So just start drag and drop at exit, that is give it our exit sensor, which is there. Emergency stop, give it here emergency, which is there. Then vision sensor, give it our vision sensor, which is there. Then start, it is start here. Then stop, it is stop here. Those are the inputs. Come to outputs. Alarm, we have alarm here. Then blue counter is going to come to, our blue counter is here. Then entry conveyor is going to come to, entry conveyor is there. Exit conveyor is going to come to, exit conveyor is there. Green belt is going to come to green belt, which is there. Green counter is going to come to here, green counter, which is there. Green turn is going to come to green turn, which is there. Gray belt is going to come to gray belt, which is there. Gray turn, have I finished gray turn? No, gray, that is green. I mean gray counter is going to come here at gray counter, and gray turn is going to come at gray turn. This remover 1, remover 2, remover 3, they have those signs there because they are started by the system. You can change it, but I've left them to be controlled by the system. So I have here sorter 1 belt is not renamed, but was supposed to be blue. I'm going to put it here at blue belt. If you was renamed to blue belt, you put it there. Then sorter 1 turn, I'm going to put it to blue turn. They didn't rename. So I'm going to have warning light. I'm going to put it here at warning light. So all, I think they are all finished. What I'm going to do, and this green tick must show you to know that it is connected. You go back. Now we are going to start our system and see if there is any error or no error. Come here to our, yeah, the problem is here. These ones are supposed to be normally open because our sensor is normally closed. So here X3 cancel. First come to write mode, put here write mode, say X3 normally open. Also here X3 normally open, X3 normally open. So wherever there is X3 you have, okay, let me first say here build. Whenever there is X3 use normally open. Here put a normally open contact of M0, then you say compile build, you say one line write to PLC, say execute, yes, okay, yes, okay, close, okay, hope it's fine. Come back to factory IO, say play, and from there click start button here, start. So let's monitor slowly how our thing is happening. blue is still 1. Wow, alarm has come. So what does that alarm mean? That alarm means this hand has not gone back because the material passed the sensor and the sensor failed to detect it. This exit sensor did not detect it. That's why it has initiated the alarm. So what do we do with the alarm? Just come here, press stop. It stops. After pressing stop, it will go back and press start again.